I seek protection with Allah from Satan, who is the refuse one, in the name of Allah, who is the most gracious and the most merciful. Today, the topic is ignorable coordinates. What is ignorable coordinates? Ignorable coordinates. To know the ignorable coordinates, first we will know what is coordinates and what is generalized coordinates. Okay, so come to the next page. So, the generalized coordinates. Generalized coordinates, to know the generalized coordinates we have to know the coordinates. What is coordinates? The set of values that shows an exact position. Actually, coordinate is the set of value which shows the exact position. For example, we know that 2 and 5, these are two set values, and it show the exact, maybe it show the exact position. This is the 2 here, the 2 exact position, also 5 show the 2 exact position. And also we can say 1 3, it show the exact position. So look at the diagram. This is the x, y, z is the coordinate system. So here we can find the position. This is coordinates. Now come to the what is the generalized coordinates. So the generalized coordinate is the minimum number of independent variable, the minimum number of numbers of independent variable which is required to describe the motion of a dynamical system. Actually, it is the minimum number of independent variable which is required to describe the motion of a dynamical system is known as generalized coordinate. Actually, it shows the motion of a dynamical system. Dynamical means the which already body in motion. Now come to the ignorable coordinates. What is ignorable coordinates? So come to the original page. Ignorable coordinates also called the cyclic coordinates. So it is actually ignorable coordinates is generalized coordinates. So the coordinates in the definition of ignorable coordinate is the coordinates, or we can also say the generalized coordinates in which some term can be ignored because of constant or conservation phenomena. Conservation based phenomena, some term can be constant. We also can say that, or the conjugate momentum is constant. The corresponding conjugate momentum when constant of some phenomena then is known as ignorable coordinates. Look at the diagram. This is the charge q1 and this is the also cyclic point of view. This is the plus charge, also it shows some field, so we can say it is the ignorable coordinates. Now for example, we say that the central force problem or central force field of a particle, the Lagrangian for this central force field is equal to t plus v is equal to l. Yeah, also we can say t minus v is equal to l. Actually it is a minus. Okay, it is a minus is equal to l. So the kinetic energy or T will be equal to a half m into r dot square plus r square into phi dot square. It is equation number 2. Is equation number 1. Now the particle, the potential energy. So we also T already find in the potential energy. We will find that the V is equal to U minus U R L. We already know it is the potential energy. Now as we know that the Lagrangian equation of pendulum or something, the Lagrange equation of derivative form is d divided by dt and to dl divided by d phi dot is equal to dl divided by d phi. It is equation number 4. We know the derivative form of Lagrangian is d divided by dt and to dl divided by d phi dot and is equal to dl divided by d phi is equation number 4. We also know that dl divided by d phi dot is equal to phi dot and to phi dot, which is and also the second term of this is equal to 0. So the phi dot and p dot phi is equal to 0. It is a constant. So in phi dot p then p dot phi into phi is equal to constant. So it show the constant phenomena. So now come to the here phi is ignorable. Now the Hamiltonian, we know phi is equal to h. This is per pi. Okay, we already know h is equal to h into r phi r into k. This is some term where operators, where k is phi pi which is constant is called, where this is also where k here is a constant, phi pi is this is also constant which is constant called the ignorable coordinates. Now the Lagrangian and now as we know from the Lagrangian formulation, L is equal to L into R phi dot R dot and phi dot, where phi dot is a net constant, applicable constant we say. Now the generalized momenta with ignorable coordinate is dl divided by d phi is equal to d divided by dl dt, and dl divided by d phi dot is a generalized momenta. So here we know the momentum and the change is, the force is equal to change in momentum. So is it a change in momentum? So generalized force is F is equal to now the generalized force is, we know that Fg is equal to minus gmm m into divided by r square, and r I unit vector. Now the Lagrangian will be L is equal to half, L will be equal to half m into r dot square plus r square phi dot square plus gmm into r. So the dl divided by d phi dot is equal to mr phi dot divided by L is equal to constant. So the gravitational potential only depend on r. Now for free particle, actually this is for different, and this is for the gravitational, we know the generalized is for generalized force. Also we also did for the generalized momenta. Now for the free particle, for free particle, L is equal to half m into x dot plus y dot square minus mgy. This is for free particle. So del divided by del x is equal to 0, and d divided by dx, dl divided by del x dot, we already know this one from the Lagrangian. Now dl divided by del x dot is equal to mx dot is equal to constant. This is for free particle. So this is equal to p, and this x is in exact position. So the px is equal to constant. So this is the generalized p is constant. These all are called the ignorable coordinates. Likes my video and also subscribe. If you have any question, then comments. Thank you so much.